Let's talk about the magnetic field due to a current. So currents, of course, are just moving charges, and moving charges create magnetic fields. And for currents, those magnetic fields end up being a series of concentric circles centered on the current. Now I've got two currents here. This one on the right, you can see we got the circle with the dot in the middle, and on the left we got the circle with the cross. This is the tip of an arrow, this one on the right. So that means the arrow is pointing out, the current is coming out. Okay. This one here, this is the tail of the arrow. So that means the arrow is pointing down or into the board, and so this is the direction of the current. So if I want to draw the magnetic fields, as I said, it's a series of concentric circles centered on the current. So I can do that. So here is a circle. And I'm going to do 3 around each of these. Now, of course, ideally these are perfectly concentric circles centered on the current. I obviously have limited artistic abilities, but I think you get the idea. Okay, so these red circles that I've drawn represent the magnetic fields, the B fields around each loop. But, of course, a magnetic field is a vector. So what is the direction? What is the direction here? Well, this involves what we refer to as a right-hand rule. And, of course, it's called a right-hand rule because you're going to use your right hand. What you do for this particular rule is you take your thumb and you stick it in the direction of the current. So if I start with this one on the right, the current's coming up and out, so my thumb is pointing up and out, and the fingers are curling in the direction of the magnetic field around that current. So in this case, they're curling counterclockwise, and so that tells me that the magnetic field, these loops, are going counterclockwise. And for the one on the left, it's going into the board, down. So I've got to take my thumb and turn it down, and now my fingers are curling clockwise. And so that means these loops are going clockwise. Now, of course, this is really just a collection of what the magnetic field is at all of these points that surround the current. If you look at a specific point, so for example, say I look right here at this point, the direction of the magnetic field at this point is straight up. The direction of the magnetic field at this particular point is to the right. And if I did here, in between them, it'd be up and to the right. And this is why we say it's going clockwise here, because you do all these and you end up just pointing kind of in this circular manner, in this clockwise direction. And we'd have the same thing over here. I'll do just a couple. Here at this point, it would be pointing straight down. Okay, and at this point here, it would be pointing up to the right. And of course here, it's an intermediate point, so it's down and to the right. Okay. Anyway, that's all there is to it.